Hi, this is Team 8 of Kim Hui-won, Lee Nam-hoon, Choa La, and Justin Chan, presenting on the Haidar Aliyev Center. First, let's begin with a review. After completing a study of the panels and the frame, we finally took a look into the interior structural design of the building. The first place we analyzed was the east wing of the building, which houses the auditorium. There, we were able to determine the solution to two problems. First, solving the noise isolation problem with a library that is only 60 meters away. This was solved through the box-in-box construction method. Second, the problem of having different acoustical requirements, of having performances with different levels of noise. This was solved with the introduction of coupled spaces. Coming out of the auditorium, we headed north to the library. How was it possible to read a book in a building with no special lighting system in view? The answer is natural light. This was achieved by the glass curtain wall creating a large window space, where sunlight can flood into the building during the daytime. The glass curtain walling was achieved by building on the foundation of a concrete structure from the construction of the main building. The frame that attaches to the concrete structure consists of a transom and mullion structure. The transoms are the beams that run horizontal on the frame, and the mullions are the beams that run vertical. The glass is then attached to the transoms and mullions. The frame is specifically designed to just support the load bearing of the glass, not provide structural support for the building. The glass curtain wall of the building required tight tolerances in assembly in order to match the high quality of the exterior of the building. This was achieved by using a unified curtain walling system. The unified curtain walling system works by inserting the already manufactured glass units into the transom assembly by means of a bracket with a sliding attachment. When the sun sets and there's no longer daylight, the building must be able to light itself. To achieve this, the Haidar Aliyev Center uses LED lights. Today, we will be taking a close look at those LED lights by analyzing the lighting methods that are using in the Haidar Aliyev Center. As seen in the photo, these LED lights are specially tucked flushly in the walls of the building, providing a clean and unobtrusive aesthetic throughout the building. We'll be taking a look at the lighting methods that are used on the floor, wall, and ceiling of the building. Achieving the lighting in the Zaha Hadid building is a very tough assignment. The structure is complex in geometry and requires lighting that is typically unorthodox in regular buildings. In addition, Zaha Hadid architects are purists when it comes to concealing and integrating lighting equipment, as it serves as an integral part of the design and structure of the building. In the Haidar Aliyev Center, because of the sleek fluidity of the building, regular approaches to the lighting would have been a disservice to the overall design. The main contractor in charge of the lighting, Maurice Bro Lighting Designer, says, "We had to fuse the lighting within the fabric of the architecture and enhance the flowing nature of the single surface that encompassed the building. But there was a shortage of conventional lighting ideas for them. To achieve the lighting in the Haidar Aliyev Center, they used T5 lamps that are versatile lamps, which are able to emit light in multiple directions depending on the application. Here, the T5 lamp represents a type of specification. T means 1/8 of an inch, and T5 means a lamp with a diameter of 16 millimeters. Considering that the 32-watt intuitive fluorescent lamp, which is commonly used in offices or schools, are a T8 lamp, it can be seen that the T5 lamp is a much smaller lamp. So how were they able to achieve proper lighting with a T5 lamp? Let's start with the floor. When designing the buildings, the architects designed a large floor trough, which separates the skin from the floor at the base of the building. As seen in the images, the troughs provide a transition break between the floor and the walls, allowing a small hidden section for lights to be installed to illuminate the walking areas of the building. In the troughs, an LED strip method was used to provide a glow along the corridor or stairs where the balustrade was installed. To attach the lights to the troughs, a regular fastening system was not used. There is a specially designed aluminum profile extrusion that sits at the base of the trough. Then, the LED lights can be housed in the aluminum structure with a diffuser that disperses the light to sit on top of it. This completes the lighting assembly in the troughs. When complete, the LED lighting assembly sits flushly in the trough, providing a smooth surface. Next, let's take a look at the ways of illumination that the lighting trough is able to achieve. The lighting troughs are special since it creates a pocket that is surrounded by three walls. Looking at the figures above, you can see that the lamps are attached inside the pocket opposite to the area that needs to be illuminated. By doing this, the light waves emitted from the lamps are reflected off the walls and into the area that needs to be illuminated. Normally, lamps are used as direct lighting methods. Although this method does not utilize the full lighting power that can be achieved from the lamps, since reflection loses some power, the reflective lighting creates a soft glow that is essential to the design of the Haydar Aliyev Center. Throughout the floor of the building, the lighting trough was used. It contained a continuous lighting detail comprising of overlapping T5 lamps, which provides a wash of lights for the wall due to the reflective lighting method. Let's move on to the lighting of the walls of the Haydar Aliyev Center. Extensive lighting studies with 3D models led to the solution of using the ceiling surface as a secondary reflector. This not only modeled the shape of the ceiling, but also achieved effective ambient lighting. The ceiling wash comes from a lighting shelf concealed along the facade glazing transom. Each shelf has double rows of high-output T5 asymmetric reflector lamps, as well as an internal row of T5 lamps to make the shelf glow. Lastly, let's look at the lighting used in the ceiling. Unlike the shelves and troughs of the floor and the wall, a new strategy was needed for the ceiling since there would be no area to install the lights. To achieve this, a three-dimensional, flexible T5 linear ceiling slot was introduced. The curvilinear detail of the ceiling slots had to be able to be mounted and adjusted to fit curving planes in all three axes because the exterior curve of the building directly joins the interior ceiling. This internal skin detail meant fabricating a ceiling slot that could be custom fit to the exact spot where it would be used on the ceiling. The solution was a three-dimensional flexible T5 linear slot detail, which could fit all the locations proposed. The linear slot was optimized to the placement and quantity and aimed to achieve approximately 100 to 150 lux at the floor level. Here is the installation process of the slots of the internal lighting method. First, they had to measure where the light would come in. Next, the ceiling of the center must be cut according to the specifications measured. Then, the holes made in the ceiling. Next, a frame and bracket is fastened into the cavity to provide a basis for the lights to attach to. The frame sits flush into the building so that it is hidden from the exterior. Next, the light fixture is attached to the frame. In the channel structure, the batten is inserted, which is the lighting assembly. Inside the batten, the T5 lamps are mounted. Lastly, it is finished off with the diffuser to complete the installation process. This is the end of our presentation. Thank you.